Alrighty, today we're looking at the zeros of a quadratic, that is recognizing them from factored form and using them to find the location of a vertex. This video is suitable for grade 10 students looking to explore quadratics and for grade 11 students looking to review from factored form. The prerequisite skills that you need. You'll need to make sure you recognize the characteristics of parabolas. That means what are x-intercepts, what are roots, what are zeros, and where is a vertex when we're looking at a parabola on a Cartesian plane. You need to make sure you're comfortable fully factoring. We'll use that to find our zeros by factoring from standard form. And you'll need to make sure you're comfortable working down to follow my own work and to show your work with your algebra. First, let's jump in. We know our factored form looks something like this. This might be review, this might be new. Either way, when we're looking at the factored form of a parabola that looks like this, then we're recognizing, okay, there are two things that are multiplying by one another. That is our first set of brackets. In this case, it's x minus something. We'll call that something an s. And then we're multiplying that set of brackets by another set of brackets, x minus something else. We'll call that something else a t. Now, those something else, the s and the t, those are the locations. Those are going to be the locations of our zeros, of our x-intercepts. So if we're looking from an equation, we might call this location t on our Cartesian plane. We might call this location over here location x on our Cartesian plane. That is where our parabola is crossing the x-axis. Now, we will notice that s and t both are being subtracted in their respective sets of brackets. That is, it's going to be the locations of our roots are going to come from whichever value is being subtracted from your set of brackets. If you're feeling a little overwhelmed here or confused, that's okay. Once you see it happening, I'm hoping it'll make a little bit more sense. It's pretty straightforward. We have some equations here in factored form. We're going to look first at question 1a, and we're going to try and find those zeros. Now, if I look, okay, 1a, it's already in factored form. There's one set of brackets multiplying by another set of brackets, and I'm saying, okay, which value is being subtracted from my x values inside these sets of brackets to come up here? In this case, I see a 6. Is this 6 being subtracted yet? No, it's not. It's being added. So really, what kind of a 6 I have in here? It's a negative 6. If I look at my other set of brackets, what's getting subtracted from x? It's a negative 2. If you're struggling to follow that, that's okay. What we're going to do every single time when we're stating our zeros is we're going to change the sign of whatever's being added or subtracted from our x. So in this case, we have an x-intercept at x equals negative 6, and we have another x-intercept at x equals negative 2. Now, I'm hoping you're following along. I want you to pause the video, try out question B, try out question C, find and state the zeros, and then unpause and see how you did. Fantastic, where you can see we've changed the signs. We're working in question 1b with x equals 2 and x equals 8. In question 1c, x equals negative 1 here, and we're working with x equals positive 3 in question C. What do these mean? These are the locations of the roots, as I said. So if I was to put, let's say, example 1a on a Cartesian plane really quickly, something like this, the locations of these vertexes, that would be x equals negative 6, so that might be somewhere around here, and x equals negative 2, that might be somewhere around here. Now, I don't see any negative signs in front of my brackets over here, and I know from the past when I don't see any negative signs, it means it's opening up. So what I have right here is a parabola that looks, in general, something like this. Where is the exact location of my vertex? I'm not sure right now. I haven't put in that work. I could have a much deeper vertex down here. I could have a much shallower vertex up high, but either way, I know what I do know right here are the locations of my roots, and that's my main point. We're going to jump into question 2. Question 2, it's going to look pretty darn similar, but you'll notice these are not in factored form. Luckily, we're masters of factoring at this point, so I want you to factor these simple trinomials, find a value you're multiplying to, find a value you're adding to, set it into factored form, and then state your zeros. I want you to pause the video here, try out question 2a, and then unpause and see how you did. Good, so in this case, we found the two numbers we were looking for, 2 and 5. We put it into factored form, and then from each of those factors, we changed around the sign of the s and the t values. That is, we're working here, the zeros are found at x equals negative 2 and x equals negative 5. I want you to try out question B, same thing. State the locations of the zeros, pause and unpause to see how you did. Good, okay, where again we found the two numbers we were looking for, -3, -6, and then we made sure that we were able to set it into factored form. Once it was set into factored form, we were able to pull out the zeros. In this case, we have two positive zeros, x equals 3, x equals 6. Now, what we're looking at doing, we're going to jump into question 3. Question 3 has us back into factored form. And once it's in factored form, then we're going to take a look at the symmetry of a parabola, and we're going to use that to find the vertex. Now, let's jump back up to the sketch of a parabola. We'll just get a little bit of a spoiler on where this is going. If I'm taking a look at a parabola, then I can see the two zeros here and here. Now let's consider, where's the vertex in relation to these two zeros? I already know the vertex is wherever my parabola turns around. But how does the location, how does the horizontal location of that vertex compared to the zeros? Well, we know it's going to be in between the zeros. We can see that right here. It shows up somewhere in between. And we're in between exactly halfway. And it will always be exactly halfway, because the way a parabola works is it's the same on the left side of the vertex as it is on the right side of the vertex. So we're going to use that relationship in order to find the location of the vertex, purely using our algebraic understanding. So let's take a look here. We're working in factored form. I want you to pause the video just for 3a. I want you to state the locations of the zeros. Good, okay, so we have the locations of the zeros. I'm going to put those zeros right on my Cartesian plane right away. So that's at x equals 1 and x equals 5. I have two zeros. My zeros are always, always, always going to show up on the x-axis. That makes sense, because what your zeros are where your parabola is crossing that x-axis. So I'm working with, what were those numbers? X equals +1, that's right here, and x equals +5, that's right here. Now, as we said, the location of your vertex is going to be halfway in between those. Well, I can see right here that's going to be here-ish. In order to show that algebraically, what I'm doing is I'm finding the middle of x equals 1 and x equals 5. To find the middle of two numbers, we add them up and divide by 2. So we're working here, the location, the x-coordinate of our vertex is going to come from taking the x-coordinate of the zeros, that's 1 plus 5, adding them up, dividing by 2. We follow our BEDMAS, 1 plus 5 is 6 divided by 2. That's at x equals 3. Is that about the horizontal location we found before? Absolutely. X equals 3 is this highlighted location. Now, if we have that x equals 3, the problem is our parabola could look something like, oh, that's at x equals 3, and we could have a nice shallow parabola, something like this. Or we could have a much deeper parabola. Here's something at x equals 3. We could have a parabola that looks something like this. I know this is really rough. That's okay. You're bearing with me right here. Or if I even compare them further or look further, I could have a parabola that opens down, something that shows up like this. So we're going to analyze the algebra that we worked with, and together we're going to find exactly, hey, where is the y coordinate of this 0 right here? So luckily for us, we have a tool that allows us, that will give us the y value if we know the x value. We know the x value of our vertex down here, and we have an equation up here that specifically is used to find y values when we know x values. We're working with y equals x minus 1 times x minus 5. And what we're going to do is we're going to substitute in x equals 3. So into this equation, that's y equals 3 minus 1 this time, multiplied by 3 minus 5. All right, 3 minus 1, we're working with a +2. 3 minus 5, we're working with a -2. What's +2 times -2? That's -4. So the y coordinate of our vertex is -4. That is, together, the coordinates of our vertex is +3, -4. I can write those over here. My vertex is at +3, -4. I'm going to put that on my Cartesian plane, use that with my zeros to sketch. So that's at +3, -4. Where does that show up? That's 3 over, whoops. Where does that show up? That's 3 over, 4 down. We're working somewhere right here. We have 3 dots. We can use those 3 dots to really roughly sketch a parabola. Nice work. I want you to try out question 3b. Same thing. I want you to find the zeros, and then I want you to find the x-coordinate of the vertex. Then I want you to find the y-coordinate of the vertex, and then I want you to sketch the zeros and the vertex on our Cartesian plane down here. Pause the video, and then see how you do. Good, so we found the locations of our zeros, we found the x-coordinate of our vertex, we found the y-coordinate of our vertex, so our vertex is at the coordinates 1, 9. So we can put all of those together. Good, my colors are going to be inverted, I apologize. We're working on question 1b. The location of my zeros is at x equals -2, that's right here, and x equals +4, that's right here. The location of my vertex is +1, +9, that's way up here. I can see this is going to be a parabola opening down. It's going to look something like this. Is this a rough sketch? Absolutely, but a rough sketch is still really valuable. At this point, you should be able to handle all the practice for section 7.6. Nice work.